All right, so now let's take this and look at some graphs that you might actually see. If we look at this, we can see that we're looking at values between -2 and 2 on the x-axis and values between -5 and +5 on the y-axis. The idea being if I was walking along the x-axis and I kept looking up and down trying to find my relation, not until I hit -2 where I'm standing on my relation have I said, found ya, and then from that point on, every time I take a step, I can look up and down and find it. So this domain, the function, or in this case it's a relation, it's not a function at all, is included in between -2 and +2. All the values between -2 and +2, including -2 and +2 themselves. And then the y values go from -5 to 5 inclusive. So in words, for the domain only, we could say x is any real number greater than or equal to -2 and less than or equal to +2. Okay, so it's contained within those parameters. The domain is the set of all x values such that x is all the real numbers where -2 is less than or equal to x, which is less than or equal to +2. Range is the set of all y values such that y is none of the real numbers where -5 is less than or equal to y, less than or equal to +5. And is it a function? And we got to give a reason. No, it would fail the vertical line test. If we do a vertical line here, it would pass through this relation in more than one place. So that is a fail on the vertical line test. So definitely not a function there. If we look at this graph and we want to describe just the domain using a number line, then we can see that if we go out here to -6, we have an open circle. So that means that we can go up to but not include -6. And if we go out here to +6, we've got another open circle. So we can go up to but not include +6. And this continuous line here and this continuous line here imply that we can take on any number of values between this -6 and 6. So on the number line, I would draw an open circle at the -6 and the +6, and then connect them with that line and just show that we're on that real number line for our x's. In terms of the domain, then we'll just use our set notation to describe x as the set of all x values such that x element of the real numbers where -6 is less than x, which is less than 6. Okay, so notice that we're just saying less than because it's open, so we can't say less than or equal. It doesn't include -6 and 6. The range is interesting because notice how, in terms of your y values, this relation does not exist anywhere below 0. At 0, you stumble right onto this relation, and then every value above 0, yep, there it is, keep climbing, yep, still have a relation, good, good, good. But as soon as we hit 6, actually the relation is not there. Okay, so at this point of 6 and above, the relation will stop existing for us. So it only exists between 0 and 6, including 0, but not including 6 for your y values. So the way we write that with our range and the notation, we'll be looking at 0 is less than or equal to y, which itself has to just stay less than 6. Okay, so again, the less than or equal applied to the 0 because that point does exist in terms of our range. Whereas 6, this upper end, when we look left and right, technically we don't see anything because these are open circles here. Is this a function? Yeah, it passes a vertical line test. Anywhere we draw a vertical line, it won't pass through this function more than once, and that's what makes it a function. All right, the last image that we're going to look at is this upside down parabola. So the domain, we'd say, well, x is any real number, because no matter which x value you choose, these arrows imply that this function, or this curve, is going to keep on going for infinity. And so no matter which x value I pick, I'll be able to find a y value on that curve. So we can show that as the domain is the set of all x values such that x is any real number. No restrictions. Okay, so no comma, no any, x is less than this, x is greater than this, anything like that. The range, on the other hand, because this parabola opens down, we can see that if you were climbing up this ladder, if you could go to -infinity on the y-axis and you'd still be able to find your parabola. But as soon as you step above 3 and you're looking for it up here, you won't find it anywhere. So this parabola, the y values where it exists are at or below +3. So we can say that the range is the set of all y values such that y is element of the real numbers where y is less than or equal to 3. Okay, less than or equal because this vertex is at the point 2, 3. So 3 is included. And is it a function? Yes, it passes the vertical line test. Okay. All right, if I were to just give you an equation, then we have to make a couple of points of recognition here, that this x has an exponent of 1 and this y has an exponent of 1. And so this is a linear relation. If we rearrange it into what would look like y equals mx plus b form, then we can see that the b value is 0, but that the m is 2. So that means it has a slope of positive 2. And if I were to just rough out a quick little sketch here, just any line with a positive slope, then I can see, oh, okay, it'll pass the vertical line test, so it is a function. And because it goes to infinity in both directions on the x-axis and to infinity on both directions on the y-axis, then there's no restrictions on the domain or range, so they're both just any real number. This one here, notice the x is squared and the y is squared. Okay, so x squared plus y squared equals 16. You may remember from grade 10 that a circle at the center, or at the origin, will have the equation x squared plus y squared equals r squared. So that means our radius is 4. So if this is a circle with radius of 4 with its center at the origin, then I can imagine that the x values would go from -4 to 4, and so will the y values go from -4 to 4. So I do a quick little sketch here just to help me rough it out. And so then we take note of that in our restrictions. So x is any real number where -4 is less than or equal to x less than or equal to 4, and for your range where -4 is less than or equal to y, which is less than or equal to 4.